Okay, this is page 2 of your Unit 9 review from our 4th period algebra class, or algebra 2 class. Again, we are solving these. If there's no real solution, state it. First step is to isolate the radical, so we do that by subtracting the negative 3. And to undo the cube root, I cube. Okay, so we get 2d is equal to negative 27, or d is equal to negative 27 over 2, which is not extremely friendly, but it's not awful, because we'll note that d is multiplied by 2. Check to see that that's plus 5. That is negative 27, and so it's negative 3 plus 5, and that works. So we're good with that. That was number 9. Number 10, again, isolate the radical. So I'm going to move that over there, so we'll get 3 is equal to the cube root of 9c. Undoing the cube root, I cube. So I get 27 is equal to 9c, or 3 is equal to c, because 27 divided by 9 is 3. I check it. To check it, I do 7 minus the cube root of 3, or excuse me, 9 times 3. 7 minus the cube root of 27, 7 minus 3, that works. Alright, so those are my answers through 10. That's 6-5. Moving on to 6-6, classify each real number as expression as either rational or irrational. That's 7, so that is rational. Okay, this is 5 root 2. We still got that root 2, so that makes it irrational. Okay, pi is always irrational. 22 over 7 is a fraction. Fractions are ratios. Ooh, a ratio is a root of rational, so that's rational. Okay, write each decimal as a common fraction in lowest terms. We've got 2 decimal places, so we're over something with 1 with 2 zeros, and we reduce. That's 253 over 50, and I think that's as far as it goes. 5 doesn't go into it, 2 doesn't go into it. So, because that's 2 times 5 squared. So, 472 over 100. Okay, so this does it a little further. That's 236 over 50. Divide by 2 again. That's 168 over 25. And, no, not 168. That is 118 over 25. And 5 doesn't go into it, so that's your answer for there. Okay, repeating decimals. Okay, remember we'll let x be equal to 0.4, 0.4444, and so on. 10x is then equal to 4.4444, so on. Okay, I can subtract, right, because what's going to happen to this stuff, that all goes away, and so I'm left with 1x minus 10x is negative 9x. 0 minus 4 is negative 4, or x is equal to 4/9. Okay. Same type thing here. X is equal to 1.272727, and so on. It's 2 places, so I'll do 100x is equal to 127.272727, repeating. I'm going to line these up a little bit better, so I'm going to take this piece here. I'm going to rewrite it underneath it as x equals 1.272727, and now I'll actually do the subtraction. 100 minus 1x gives me 99x. Again, that stuff's the same, so it cancels, so I get 127 minus 1 is 126. X is equal to 126 over 99, which is reducible. 9 goes into both of them. You get 14 over 11. Alright, simplifying. That's 3 times 2i, so that's 6i. This is the square root of negative 1 times 9 times 5, so that's 3I square root of 5, because I can take that out and that out. Okay, that's it for page 2. Page 3 will follow.